Hello! Together with a new, bigger model of a robot head comes an update to the face tracking web app. This version uses the most recent model of Mediapipe, which is a face tracking algorithm from Google, and it works much smoother and much more precise, to the point that we can measure left and right eye openness and the amount of smile. And this is actually quite funny, because smile is simply measured by the width of the lips. So we can use this feature to detect smile when the lips get wider, and when the lips get narrow we can detect kisses. Of course, other parameters such as moving the face left and right, yaw, pitch and roll, distance and mouth openness are also available. The app is compatible with Microbit and Calliope Mini microcontrollers, and on Cardboard Robot's website you can find code template that you can adapt to your robotics projects. As always, the app works in the browser as a web app, so you can use it on most desktop and mobile devices. On iOS it will work in a Bluefy web browser. And here's a quick lesson how to exactly program my big robot head or any other robot you build with the Microbit board, how to make it compatible with my face tracking app. I have a basic code template here, and it might look a bit intimidating at first, but it is in fact quite simple. What happens here is that the board receives the data from the app, the face tracking data, by Bluetooth. So we have Bluetooth initiation on start, on Bluetooth connected, on Bluetooth disconnected blocks, and on Bluetooth data received. And here is the block that will receive the data from the Bluetooth from the face tracking app. And the data comes as a big block of 20 characters of text, in fact, which we have to chop into pieces and convert into numbers. And this is exactly what is going on in the first part of the code. Like this part is universal for all of the robots that will be using this app. So we take the data received string from the face tracking app and we chop it with the substring block. The data is transferred as text. So the first thing we do, we cut substrings of this text, parts of this text. Each two characters or one character is connected with a specific property from the app. So for example, when we take first two characters of this data, so starting from 0 and length of 2, this is the value of the x coordinate of the face. We take another part starting from the second character, length of 2 characters, convert it to number, and this is the property of y position of the face. And so on with all of the other parameters: z, the distance, yaw, pitch, mouth, left eye, right eye roll, smile, and face visibility. And now we can access all this face property by variables created here in this project. And now when I want to transfer this to my robot, here I have part of code that controls my robot. And as you can see, I'm not using the regular Servo blocks because I'm using a specific adapter for the Microbit. For each project, every one of you can have any other adapter. If it has any specific blocks to control servos, use that's what you have to do for your specific hardware. Mine is the DF Robot adapter, which uses these servo blocks. And for example, servo number 3 here in my robot is connected to the jaw. So it will be assigned to the mouth value. And this part here is important, the mapping block. And it is important because each servo can move from 0 to 180 degrees. And when I put it into my robot has specific construction, and then I do not want this servo to move freely between 0 to 180. I have to limit its area of movement to some specific values, and these values has to be checked manually in the process of building the robot. That is why I show this in the process of building, to connect this servo tester and set each servo to 90 degree. And later it is also useful to check each motor in the robot in which range it can actually move, not to break the robot. So I know that the value from the app, the mouth value, changes from 0 to 100. I limited it here a bit between 0 and 90. And then I checked before that in my robot, the jaw should move between 0 to 50. So I use this map block to map the value of the mouth variable, and I know that this value changes between 0 and 90, and I want the output of this block to change accordingly, but between 0 and 50, to translate between these two ranges. And this type of calculation should be done for each movement, for each motor. I have pitch here, yaw, left eye and right eye. There are 5 servo motors in this robot. And for each of these servos, for each of these motors, I checked manually in which range should they move. Like for example, in left eye, I checked manually that the eye is closed when the servo is set to 135, and the eye is wide open when the servo is set to 33. So I map the value from the left eye, which changes between 10 to 60, and I map it to the range from 135 to 33. And in the right eye, it is from 0 to 98. Each motor has to be checked individually.